Alrighty, so section 6.4 is all about what are called inverse functions. Well, let's talk about inverse functions. We first kind of remind ourselves of what a function is. A function has exactly one output for every input, or remember, no input values repeat. So more generically, we talk about inverse relations, which means you might have some repeating output values, and that's okay. So an inverse relation is just the set of ordered pairs obtained by exchanging the coordinates of each ordered pair. So this is really important. It means that our y coordinates become x coordinates and our x's become y's. So the graph of an inverse relation is a reflection of the original graph about the line y equals x. Well, that makes sense because y's and x's get swapped, and so we reflect a graph across the line where those two things are equal. And then just a couple other things to note that we're going to use here later on. To find an inverse relation or inverse function, you exchange or swap x and y, and then you solve for y. We often replace y at the end with, the notation is f, instead of f of x, we have f with a little -1. That means f inverse of x. So when you read this, we read it as f inverse of x, just like we read this guy as f of x. So make sure you're saying it correctly and using proper notation. And then if both the original relation and inverse relation are functions, in fact, we call them inverse functions, right? That would seem to make sense. And then if you're trying to confirm whether two functions are inverses of each other, what you do is you compose them with one another. You find g of f of x and f of g of x. They should both just equal x, which is kind of cool. So first thing that we're going to do in example 1, we want to find the inverse of this guy right here. Well, this function f of x is 4x plus 2. So what we do is we start with that. And then instead of f of x, we know that f of x is just a fancy word for y, right? So when we first write it down, we're going to say y equals 4x plus 2. And then our first job, if we're asked to find an inverse relation or an inverse function, is we said from up above, we swap x and y. So now I have x equals 4y plus 2. And now I want to solve for y. Well, I need to subtract 2 from both sides. So I have x minus 2 equals 4 times y. And then the last thing attached to y is the 4, which is attached by multiplication. So to undo it, we use division. So y equals x minus 2 over 4. And then we said that if it is a function, we can use function notation. So not only is this y, but this is f to the negative first of x, so f inverse of x. And it does equal x minus 2 over 4, and this is a totally perfect answer. We are, however, asked to graph both, so it's a little bit easier if we think about this in terms of y equals mx plus b form. So what we can do is what I call distribute the divide. So we can take, actually I'm even going to color code it. So we can also call f of x, f inverse of x, x over 4, which instead of x over 4, if we want to know what our m is, we can call that 1/4 times x, right? And then minus 2 over 4, well, 2 over 4 reduces to 1/2. So either of those would be perfect answers for what is my inverse function. For the sake of graphing, though, we are going to be using that second one more often. So we want to graph both our regular and our inverse. So our regular, y equals 4x plus 2, our m is 4, and our b is 2. So our graph starts at 2, and we move up 4 and right 1, as well as down 4 and left 1. And we connect those points with a relatively straight line. So there's our original, there's our f of x, and then we'll also graph our inverse. And our inverse, that looks like our m is 1/4, and b is negative 1/2. So we go down 1/2, and we move up 1, which puts us, okay, if we start at negative 1/2, moving up 1 would be at positive 1/2, as well as right 4. And then up 1, right 4, go back to our y-intercept, down 1 and left 4, down 1 and left 1, and we connect those points. There is f f inverse of x. And then next in example 2, we are verifying that those two guys are in fact inverses of one another by finding f of f inverse of x and f inverse of f of x. So when I find f of f inverse of x, well, my f function said take 4 times your input and add 2. Well, this time our input is f inverse, which is right above us, 1/4 x minus 1/2. So we start by distributing that guy. 4 times 1/4 is just 1 times x. And then 4 times 1/2, if I have 1/2 of 4 people, that is 1/2. Oops, no it's not, that's a lie. It's 2. And then plus 2, sorry about that. And then if I have x, I subtract 2 and then add it. Those two guys cancel. I just have x, which is what I'm supposed to get. And then we just need to verify again, not only do you have to do f of f inverse, you have to do both. You have to also do f inverse of f of x, which for us is going to be, well, take 1/4 times f and then subtract 1/2. Well, f of x is saying 4x plus 2. So then we simplify from here. So we distribute that 1/2, that 1/4. 1/4 of 4 is 1 times x. And then there we go, 1/4 of 2, there was my 1/2. And then we've got that minus 1/2 outside along for the ride. And then notice we've got minus 1/2 plus 1/2, reverse order, but still. And so that means we just get x. So since f of f inverse equals f inverse of f, which is just x, they are in fact inverses of one another. So if you're ever asked to determine whether two guys are inverses of one another, you plug one into the other and then you make sure to do it in both orders.